Hello everyone. Today I will show the solutions to the Prairie Math League High School Round 134, Problems 5 and 6. To start, we have to find the number of three-digit numbers such that its first two digits are each divisible by its third digit. So, in other words, if we have the number in the form ABC, this is not a product by the way, then we have C divides A, C divides B, and A is not equal to 0 because otherwise it would be a two-digit or even one-digit number. So now we can just do casework based on C. So first of all, note that C cannot be equal to 0, or else we would just have like a bunch of errors, and mathematicians don't like to deal with errors. So starting from C equals 1, we see that we have all possible values from 0 to 9 for B and 1 to 9 for A. So we have 90 ways. And we can continue this for C equals 2, 3, and 4. And we get 20, 12, and 6 respectively. Finally, if we have 5 or more, so if C is equal to if C is greater than or equal to 5, or less than or equal to 9, then there is no other divisor of C, or sorry, multiple of C, other than 0 and C itself. So we have 0n, we just said equal to n, 0n for B, just n for A, and that gives us two possible ways. And again, we have from 9 to 5 inclusive, so this gives us 5 values in this case, and 1 value for each of the other cases. So now we just add them up to get the answer of 138, which is B. For problem number 6, we have for each positive integer n up until 2023, we have a parabola that intersects the x-axis at points a sub n and b sub n. And let a sub n, b sub n in absolute value brackets denote the length of the line segment a n, b n. And we have now, then we're given to, we have to find the value of this expression here. Now, the first thing we can note is that if we have a parabola like this line segment is just the difference of roots. So if this has roots a and b, lowercase a and lowercase b, then this distance is a minus b absolute value sign, where a and b are not points, but they're just numbers. So for any n, we let the roots be a and b, as we saw here. Then we use VHS formulas to get the sum and product of these roots. Now, the sum of any root, or sorry, the sum of the roots of any parabola is equal to the center term divided by the outer term and take the negative. In this case, the center term is actually already negative, so the center term is already negative, so we divide it by the first term to get 2n plus 1, or negative 2n plus 1 over n squared plus n, and the negatives cancel. Now we need to have the product. The product by VHS formulas is the last term divided by the first coefficient. So in this case, it would be 1 over n squared plus n. And this time there are no negative signs. Then we want this value, as we saw here. So note that negative a minus b absolute value sign is equal to the square root of the expanded form of the a minus b squared. So in this case, we see that a plus b squared is equal to a squared plus 2ab plus b squared, which is slightly different from this value here, in that it's a plus 2ab instead of a minus 2ab. So we offset the difference by subtracting 4ab from a plus b squared. Now notice, we have this now, and we have this in this expression. So we can substitute s squared minus 4p. And we actually don't even need to substitute s and p, we can just substitute this and this. Now this might be a little tedious, but if it's all done right, we should get this, where in this case we actually multiplied both the top and the bottom of this fraction with n squared plus n. So now the denominators match, so we can cancel out terms. This cancels with this cancels with this, and we're just left with the square root of 1 over n squared plus n squared. And this results in 1 over n squared plus n. Then, now we're going to use a very powerful technique that can solve problems with huge sums very easily. So we start by using partial fraction decomposition. And to do this, we note that n squared plus n is equal to n times n plus 1, just simple factorization. Now here's the tricky part. We have to add an n, but in doing so, it's not equal to this number anymore, so we have to subtract an n to make it equal. Now we can actually split the fraction into two parts, the part containing the n plus 1 and the part containing the minus n. So now we have n plus 1 over n plus 1 minus n over n plus 1. Now it's important to notice that this is still the same as this, because we still have these two things. Finally, we can cancel this out and cancel this out. Note that neither n and n plus 1 are ever equal to 0. So this simplifies into 1 over n minus 1 over n plus 1. In other words, we're able to simplify this expression into this expression. Now this might not seem so useful, but it's going to be very useful in the light of the next technique, which is called telescoping. So for all n from 1 to 2023, we note that this new thing actually makes it look like 1 over 1 minus 1 over 2, plus 1 over 2 minus 1 over 3, and so on, plus 1 over 2023 minus 1 over 2024, and etc. But now notice here, because we cleverly set up so that the n plus 1 for this n is equal to the 1 over n for the next iteration of n in the summation, we can actually cancel a bunch of things out. So here, minus 1 over 2 cancels out with plus 1 over 2. Minus 1 over 3 cancels out with plus 1 over 3. And we can cancel out the ugly stuff in the middle. And eventually we get 1 minus 1 over 2024, which is equal to 2023 over 2024. This is option C. And we're done. If you're lucky, you might see partial fraction decomposition also used in calculus. Thank you for watching.